So I'm here in the Joby hangar, and this is pretty much the first time I've been in a hangar where you can't smell jet fuel. And that's because these bad boys behind me are powered by lithium-ion batteries. But we'll get to that here in a second. I'm Ryan Bodenheimer, better known on YouTube as Max Afterburner.
Having flown a Thunderbird jet myself over and over and over again, you become one with that aircraft.
And I've spent a career flying in high-performance jets at the leading edge of what's possible. From F-15E Strike Eagles to performing air shows in F-16 Thunderbird jets, I know what it feels like to pull 9 Gs, feel the G-suit inflate, and to operate on the absolute edge of physics. But aviation isn't just about the few that get to step into high-performance fighter jet cockpits. It's about moving humanity forward. This is Joby Recon. It's a behind-the-scenes look at the aviation company that's changing the game. And we aren't just looking at a new airframe here. We're looking at a fundamental shift in how we live by introducing high-performance aviation into your daily commute. Don't like traffic? Well, neither do I. This aircraft could solve that. But to make this vision happen, it takes something special. We're going to explore the aircraft, the engineering, the people, the entire ecosystem that Joby is building to support this new vision. Today, we're giving you an overview of the aircraft, the electric air taxi getting ready to deploy in cities around the world. Welcome to the future of flight. Didier, thanks so much for having me here today.
Thank you for coming. Really excited to have you.
Can you tell people what you do for Joby and where we are?
Yeah, so I'm Didier Papadopoulos, and I really run the program for Joby Aviation, so the Joby electric aircraft. Today we're here at the flight test building. This is where all the cool things come together, and we exercise sort of the flight test program. Anything from the aircraft that we intend to commercialize, which is a battery electric version, to a turbine hybrid version, as well as a hybrid fuel cell electric aircraft.
Well, as a pilot, so for me, I'm always thinking of how does this thing operate? I just want to get in and fly it. But it's because of people like you that pilots have a good system to operate. It's integrating the perspective of pilots and engineers that I'm noticing Joby's doing pretty well.
You know, as an engineer, this is going to Legoland in some ways. It's really exciting because you get to interact with the pilot, get some of the feedback, and then very quickly go back to the design and the manufacturing side of things and fine tune and make these adjustments very quickly.
Can we walk up and check out the aircraft?
Yeah, let's take a look.
Okay, cool. So the thing I noticed right off the bat as we walk up to the aircraft is redundancy, right? Redundancy and power. We got 6 power generator systems.
Safety is number one, right? And that's what drives redundancy in our system. We got 6 propulsion systems. Every one of these is actually 2 propulsion systems in one. For a propulsion system to fail, you actually have 2 failures to happen at the same time.
Aviation is inherently risky, but when you mitigate that risk, that's the name of the game.
When we're designing aircraft, really thinking about safety in everything we do. In fact, this aircraft has flown in a lot of conditions already today where we literally shot down some of these motors on purpose in order to operate in a failed condition. It was really no impact and no effect on the pilot. That's sort of pounded in everything we do in this company.
Yeah, that shows you how engineers' brains work. They purposely break things and then test and see if it can keep working.
That's one of the fun part. That's the fun part, actually. Breaking things is fun.
That's a cool part of the job. So do you think that having 6 blades, does this make helicopters feel insecure? They just have one?
Probably. It is the number of blades, but more importantly, I think, when you compare to helicopters, that's a great point. It's about how quiet we are. When this is flying, you and I will continue having a discussion just like this, and you'll barely notice.
That's insane. So 65 decibels, right, is what it operates at. Can you talk a little bit about the blades themselves? Like I noticed on the end of the blades, it's curved down.
So the design of the blade is one of the factors that drives the acoustics. Other elements of that also is the length of the blade, right? Part of the reason you hear helicopters so loudly is because the tip of the blade is so far. The acoustics is in relation to how fast the tip of the blade moves.
Some of those tips can get supersonic on helicopters,
yes,
right?
Exactly.
Not exactly quiet.
And we also spin at a lot lower speeds.
It's a lower speed, so you're operating at a lower RPM, lower sound, lower energy usages?
That's correct.
Okay.
Yeah, and high torque at the same time. That's sort of the advantage and the beauty of moving to electric propulsion.
Nice. So the wing itself, though, that's something I noticed when I first walked up. So to me, it looks like it's like a bodybuilder or like a gorilla, like flexing. Why is it shaped like this? Can you tell?
No one's ever talked about it that way, but
yeah,
I
makes
like
me want to
that.
hit the gym. I want to go hit the gym now.
A lot of what we designed the aircraft about was sort of obviously the aerodynamics and the efficiency of it, but Another key important part is sort of the ease access to the aircraft. So part of the reason the wing is where it is and the reason it is this way is we want to make sure that you're easily able to access the aircraft.
So
ergonomics for the passengers is a key part in everything we design as well.
Imagine that, thinking of the passengers.
Yes.
You didn't just think of the pilots.
Number one customer, not this time, not this time. So one of the things that is really unique about our design is we get to control not only every propulsion system by itself, but we can also control the pitch of the blade, we can control the RPM of the motor. All of these are independently controlled so that the passenger ride and the pilot ability to fly the aircraft is optimized. I would say also that redundancy is not just in the propulsion system, it's also in the battery as well. So we've got 4 batteries and they're also redundant and independently wired to the propulsion unit so that if one of those were to fail, then the other ones can pick up as well.
In like commercial aviation news lately, there was like a UPS incident where the engine literally rips off of the plane, right, as it's flying. What have you guys done for the security of these engines to make sure that something like that catastrophic doesn't happen?
I love all of the horror stories.
I gotta ask the tough questions that people want to know.
But in this case, by way of example, also even our tilt mechanism is redundant, right? So you've got 2 tilt actuators within the system, and the tilt mechanism itself is redundant.
Something I also noticed too that people might be interested in is like how the landing gear look. It looks to me like low profile is how I think of, right? So this thing isn't going to land on an aircraft carrier anytime soon, right? At least in the like forward motion type of way. It's going to be the vertical takeoff and the vertical landing, which is different than the F-35. F-35 is vertical landing, but short field takeoff, which I don't think a lot of people know that. They think the F-35 can do both, right? This one can do both.
That's correct. So we want to be able to pick you up from the closest location you're in, and we want to take you to the closest location you want to be. Generally speaking, that means taking off like a helicopter, cruising like an airplane, and then landing like a helicopter.
And that probably reduces weight too.
That's correct. Weight is everything. In most of the things we do here, we optimize for weight. Optimizing for aircraft weight means more weight for passengers. It also means less energy consumption. It means longer range and so on.
Optimized for weight. This thing hits the gym, basically.
It hits the gym every day. Like you said, it looks like this.
I mean, we could call it the gorilla. I don't know if you guys have
I like that. I like the gorilla. We'll put it to the marketing team.
Okay, sounds good. Engineering has come first, right? Like redundancy, mitigating the risk as much as possible, but then also user interface, visuals for the people flying in it. Kind of look at it like an engineering and art. Engineering needs to come before the art, and to make sure it's mitigating the risk. But can you tell us a little bit about the simplicity, the visuals that the passengers are going to see and the pilots are going to see?
Pilot experience and passenger experience is king, right? And in some ways, all of these things sort of work together. One of the key things we worked on, for example, in terms of visuals, you see all of those big windshields, right? We want to make sure that the experience is open space, that you're able to experience not only the inside of the cabin, but see the world outside.
Oh,
that's kind of the beauty of flying.
With the simplicity of the cockpit, you're going back to a pilot mindset of situational awareness on the big picture. So looking outside, looking for weather patterns, looking at terrain, looking for other aircraft. When there's 500 switches around you, some of the aircraft I've flown, literally 500 switches, right? And you're looking down a lot, and that's not good for situational awareness. So I love the fact that this looks so simple, and I think it's going to be an iPhone moment for pilots when they actually can see how simple this thing is.
For us, that's one of the key things also in getting the sort of the new generation of pilots excited about this industry, excited about flying this aircraft. And yeah, I'm looking forward to getting you on the simulator and seeing how what you think about it.
I can't wait.
And you keep asking me, can you learn to fly it, right?
Put me in, coach.
Yeah, so put you in with the best out there. Buddy is our chief test pilot, and he's gonna show you how to fly the aircraft, and then we'll put you to the test.
Awesome.
Sounds good?
Thanks, Didier.
Awesome.
All right, cool, here we go. So
All
we're ready,
right.
buddy, here we are.
We're here. So you got the basics flying the F-15, F-16, so you know how to fly fighters on what's a front side approach.
Yep.
So this is go fast, go slow, max afterburner over here.
Thank you for working that in.
Yeah,
Finally,
no worries.
plug.
Somebody. So this was a big debate and discussion when we looked at the Harrier, which was very hard to fly.
Right.
Accident rate was 10 times that of the F-16 on its introduction and remained that way through its life. So we set out with a program to look at how do we reduce accident rate, how do we lower workload, which should go hand in hand, how do we make this airplane easy to fly. So the Harrier had throttle, engine control, nozzles for the nozzle vector, which we have vectoring thrust, and then the conventional stick. all of those inputs were coupled into the airplane. So if you wanted to set a flight path and slow down, you had to pull power off the engine, move the nozzle vector lever, push the vector down, and which pitched the airplane, which you had to compensate. So you were constantly making corrections.
So complicated.
Left and right hand.
Yeah.
And at night in a pitching deck trying to get back aboard the ship. So we set out to solve that problem. We set out to eliminate the levers and knobs in the cockpit. We did that through the magic of matrix mathematics and a control system called Nonlinear Dynamic Inversion. What does that mean? That just means we carry the entire knowledge of the airplane on board in the control system, and what we hand you is direct command and control of what you want. I want flight path up and down. I want speed fore and aft.
Awesome.
And I want direction left and right.
Sounds like you really reduced pilot workload.
It really
That was the goal.
collapsed pilot workload.
Wow.
For you, it's quite easy. So when you join in formation on another airplane, what do you do to go forward and aft?
Just a little bit of power.
A little bit of power forward, a little bit of aft. So you're controlling fore and aft over here.
Yeah.
And you're controlling where you are left and right, lateral stick.
Right.
And you're controlling how you are up and down over here.
Some pitch.
So all you got to think about now is, oh, well, the hover task is just a formation task that you learn. So now the skill set you learned in a fighter directly applies to an airplane that hovers, because I'm just formatting on the pad. So now it starts to make sense. You close the gap, slide over, line up, come down and land. Once you make the job easier, then teaching people how to do it gets even easier. So the training burden becomes very simple, and we can train people to be proficient in how the airplane operates. And then there you have it. That's the whole package put together.
Seems like you thought of everything, but does it have an espresso maker?
In back.
Back? Let's do it. Yeah.
Push for coffee bar. All right. So any questions? That's as easy as it gets. That's all the training you need.
Right on. All right. Being cut loose. I do like the ergonomics of this though, like how it actually gives you support on, like when I was flying on the Thunderbirds, this little rest right here, you had to have it just to steady your hand. And the fact that, you know, you're gonna be flying 5-6 sorties a day in this, having that is important. People might not know that. So the ergonomics in that design, that's really smart. Yeah.
And you feel the positive control.
It does feel comfortable. Yeah.
You can find out the relative deflections across the demographic spread that makes that nice.
Okay, sounds good. Yeah, for the viewers watching, it's not hard to move, but you can definitely tell and know where you're at. And that was something on the flight on the Thunderbirds as well. Sometimes it was hard to know exactly where that stick deflection was and how much you needed to put in. But this, to me, it looks like you're more aware of where that full deflection is, even without looking at the instruments. I can tell, which is kind of cool.
No need to reinvent the wheel.
Yeah, and that's so cool. You guys took lessons from all those different airframes, and there wasn't like a, no, we're gonna fall on our sword and just do it the exact way the Harrier was done, or the exact way this was done. You're learning and you're taking information from a lot of different systems.
Believe me, that was a cultural battle to get over, because people only know what they know. They don't know what could be better. So trying to break the Harrier paradigm, trying to break the helicopter mindscape of, hey, we're splitting X and Y across the two hands. Technically, it was very easy. The cultural battle to get that through the community was the challenge. Pull harder, you're gonna go faster.
So you gotta be kind of careful not to tilt it as you do that if you want to maintain straight. That is sweet. Wow, that's so responsive. Oh, this is fun. For the viewers out there, I'm just doing a left roll input and it's just holding altitude. Perfect, which is not normal. It's a lot less workload than a normal aircraft. That's cool.
All right, let's come to the right side of the East River. We're gonna come back and land on that vertiport. Okay. So just follow the shoreline down over there, holding height here. That's good. Just we're descending.
That was amazing. I literally feel like some of the same feelings as when I first flew airplanes in flight school, where you just feel that excitement because it's something new. Buddy, thanks, man. I really appreciate it. This is awesome. Gosh, that was so fun.
You asked a lot about redundancy, safety, and sort of breaking things. This is called an integrated test lab. And the integrated test lab is effectively just the last step where we test things before they go on an aircraft. All of the electronics that goes in the aircraft, we break it on purpose and see if the aircraft continues to behave well. This is one of the most exciting things for an engineer, because this is where all the hard work comes together in one before we can say, okay, put it on the aircraft, it's ready to fly.
That's so cool. Can we walk in there and look at some of the systems a little bit?
Yeah, absolutely. Let's go all the way to the end.
I just feel smarter being in here right now. I don't know why.
So this is a cool example of, we have effectively 2 actuators in the lab itself where we're exercising those things.
These are what's on the actual aircraft we were just at. And that's helping it rotate.
Exactly, it's helping the tilt mechanism.
Nice.
And we can shut some of these off and see if the aircraft behave accordingly. And if I were to step in here, you can see that we've got the motor also assembly.
Yeah.
So we're actually running the real motor in the lab. So we could do some of those same failures here. All of the flight control computers are effectively sitting just with these boxes.
Okay.
Some of these boxes are actually, we call them emulators. It's what injects a failure in a flight control computer.
So it's like red team. You're like red teaming.
Exactly.
So for the viewers out there, so red team and blue team, red team acts like the adversary, comes in and inserts things into the blue force, which are the good guys, and tests to see, does the system keep working? And that's what you guys are doing right here. And you guys are being brought in and you're seeing it right now.
Because we plan for that and we test for it.
You're testing it over and over again.
And over.
Yeah, pretty badass. Like, that's just cool. You have to plan for those anomalies and you have to do it right here on the ground at 1G. So then when you get up and you're flying, it's a piece of cake, right?
There's a bit of engineer in him for him to call this badass. I like it.
I just like to nerd out on this stuff. But yeah, it is badass.
I love it.
All right, everybody, so we're here with Didier in the manufacturing side at Joby Aviation. Didier, can you tell us a little bit about what's going on?
Yeah, so this building is where we do all of our composite parts. Most of the Joby electric aircraft is made of composite parts, and this is where it all starts. A lot of the composite parts we do here are primarily done in 2 ways. One is a method called hand layup, where you effectively have a flexible composite material that you cut to shape based on the design the engineers have completed, and you literally lay it up in molds in preparation for curing afterwards and sort of making it a hard part. All of this gets assembled, obviously, and finishing up with an aircraft. The other method of doing that is through some of these cool robots that, just like the one behind you. But the advantage of this is it's a lot faster and much more repeatable. So larger parts, you use robots. Smaller parts where you need intricate and detailed hands, you use sort of what we call the hand layup.
Okay, nice. Did you name the robot? Is that a name?
Man, you want to name everything. I love it.
Yeah.
I think we're going to give you a big list of things to name.
This could be Silverback because of the silver, the silver on the back of the up there.
I love it.
All right, cool. We'll work on it. We'll work on it.
Silverback.
Yeah. All right. All right.
So once we cut the parts, we bring them here, we cure them in a big oven, and then that gives it all its strength and rigidity that we really need for an aircraft. This is one of the examples of the parts that you're able to make. Remember how flexible these materials were before, and look how hard and rigid it is now. This can take a few hours depending on the temperature and the pressure you use.
Okay.
And really the way you do that is you cook it in ovens we call autoclaves.
So is this whole thing carbon fiber or just the parts that kind of look like that traditional
The whole
carbon
thing is
fiber?
carbon fiber.
That is so cool. I mean, it's so light. I wish everybody could like feel how light that is.
Almost impossible to break.
Well, I mean, I could probably, if I did it.
That's why I said almost, because I knew you would say that.
I'm not predictable. Okay, yeah, you're probably right.
One of the things about these ovens is you got different sizes of them. You got a small one here, a medium, and then a large one.
So the entire wing can go in there all at once. Everything gets baked in and kind of it seals it together. Is that the way to think about it?
It really gets the moisture out, so to speak, and cures the adhesive material that's in the composites.
Wow. Does it double as like a like a bomb shelter?
We haven't thought about it that way. That could be good.
That's awesome. That's
I always
really
think about roller skating inside. If anybody can do it, I feel.
Let's do it. Yeah, let's do it. I'm in.
This robot effectively is checking all the parts for potential defects like voids and things like that. What it does is it scans a part, and as it's scanning it, it's literally just showing water, and it's listening to the echo, and based on that, it could tell you whether there are defects in the part.
Wow.
It allows you to sort of inspect larger parts faster and in a more repeatable way.
So we're headed to the next manufacturing area, and like obviously Joby, the aircraft are cool, but they got custom minivans as well, something that they didn't tell us about. So might be one of the coolest parts of the whole trip, custom minivans.
It's not just a minivan, it's a Toyota.
It's a Toyota, yeah. And it's custom, come on in.
All right, you go in front.
All right, I'll go in front.
And this is what we call the sub-assemblies happen. So this is where we put the wing together, It's whether we put the fuse together and the tail together.
No big deal. They're just building aircraft all around us.
Yeah, just making aircraft everywhere.
Do you feel cool when you walk in here?
I do feel cool because I feel like I'm in a playground. So if you take a look here right behind you, this is where, remember how we said we take those wing skins and we bake them in that big autoclave, that big oven? When we're done, we ship them here, and this is where you start assembling it and get that full wing. So that's the wing that's gonna eventually, after we assemble it, start housing all the electronics, the batteries that we talked about earlier, all the wiring harnesses and so on. So the team here is really multi-skilled. They're doing all kind of things on that side. We're really here trying to innovate. We're trying to create something new. We're trying to take advantage of the latest and greatest in terms of technologies. We can really do that leap in aviation that is necessary for this market.
Can we do a selfie so I can brag to my engineer friends?
Yeah, absolutely.
Okay. Done. All right.
All right.
There's the wing.
Cheers to engineers.
And pilots.
And pilots.
Hey everybody, so I'm here with Jon Wagner in the Joby battery facility. Jon, how's it going, man?
Really good.
Hey, nice to meet you. What's your role here at Joby?
Oh man, it's a lot of things.
Man of many talents.
I suppose, yeah. I've been here a long time and I've worked on a lot of things. But I'm in charge of what we call the powertrain and electronics. It's everything in the airplane that has electrons flowing.
So you're saying you're the star of the show without saying it. I mean, you're an electric...
Not at all, no. My job is to build a team that can do that stuff.
Well, you've done a great job. I mean, walking through here, seeing how everybody's just dialed in, I mean, it seems like this place is working like a well-oiled machine. So the first question I have for you is, so getting into that sim, as soon as you hit I want to fly, literally you're flying within about 2 minutes after that. So for me, having flown these legacy jets, you got to warm them up for 20, 30 minutes, right?
Yeah.
And so that's new to me, but you're putting so much power through that aircraft right away within 2 minutes. So how do you do that without, you know, having things pop off prematurely?
Electric propulsion is just so different. You know, we're not burning fossil fuels. We're not having to bring things up to temperature and equalize their temperature. You can just go straight off. From the very beginning, this was always meant to be carrying people. Yeah. I mean, air taxi is the mission, right? So we want to get people in the plane and get them off on their trip. And when we get there, we want to shut down and get them out of the plane. You know, the moment the wheels touch the ground, we spin down and you can get out. Nice. You're not waiting or you're not ducking your head like a helicopter.
So what's your perception of pilots? Side question.
We're super integrated as a team. We've hired some of the best pilots in the world. Yeah. And so it's just been an absolute pleasure working with that team. Yeah. And they get into the engineering and we get into the piloting and it's been great.
Yeah, that's super refreshing to see. There's some like, I guess, bad rap with pilots and engineers like kind of competing, right? In some companies, but I don't get that vibe here.
Right in the beginning of the company, our founder, Joe Ben, set us up with the expectation that should this be successful, we need to have thousands, tens of thousands, and maybe even hundreds of thousands of airplanes all over the world.
Yeah.
And then the very next thing you ask is like, who's gonna fly all those planes?
Yeah.
And you're like, well, you know, eventually we should go automated, but we're gonna have pilots for a long time. Yeah. We know we will.
See pilots out there, take a deep breath. You're okay. Your job security is okay.
To have that many pilots around the world, we gotta make it easy to train pilots. We gotta make it easy to fly the plane. We got to treat pilots for what they're good at, right? Yeah. Making decisions with new information is why we have a pilot.
That's awesome. If I'm going to jump in a Joby, I'm thinking, you know, as I do in a fighter jet, propulsion, you know, what's going to keep me airborne?
Yeah.
So I've never gotten in a plane and thought, well, lithium ion batteries are going to keep me airborne.
So this is my favorite thing to show people. This is the enclosure of our battery module. In the airplane, there's 28 of these.
Okay.
They're arranged in groups of 7. So 7 of these, in fact, they sit in the wing, and this is kind of where the wing shape comes in. So they're long and thin. So 7 of these stack up in the wing. Okay. You connect those together to make a battery pack. So there's 4 battery packs. Okay. 2 in the inboard nacelles and 2 in the inboard wings.
Okay.
The way it's designed is those 4 battery packs are separated into different zones of the aircraft. So if one of them is overheating, it's not affecting the other 3.
Nice, so there's separation between them so they're not bleeding through.
Exactly, so we have electrical separation. So if we have a wiring fault or electrical fault, it doesn't affect the other 3. Essentially, the reason we have 7 of these is that even within that battery pack, we have sort of a 7-piece separation. And then this, I'm gonna hand it to you, that's a titanium shell.
Wow, it's really light.
It's super light. We selected titanium because obviously it's very high strength and lightweight.
Yeah.
But one of its most valuable assets is it's great at high temperature.
Nice.
So this is the all condition containment. If any kind of failure happens in the battery, this guy is going to contain it and keep it from propagating anywhere else.
Okay, so when you go to the airport, right, you check your bag and they're like, hey, are there any lithium ion batteries in here, right? And you're like, oh, no, you don't put lithium ion batteries in what you're checking. You guys are purposely putting a ton of lithium ion batteries up in the sky.
Yeah.
So how are you cooling them? What's cooling them and what makes that good to go?
Yeah, no, I mean, number one, look, we don't put batteries in the cabin.
Right.
That's like number one.
Fair enough.
From the very early days, we just said, let's get the batteries out away from passengers. Let's not put them under the floor.
Nice.
Let's get them out in the wings.
Yep.
Let's make sure that there's no connection to the cabin. We've got a fairly advanced cooling system. This is one of the cooling plates. So this is made out of titanium. This cooling plate has integrity throughout any kind of failure as well. That is actually more important, it turns out, for charging than it is for flying.
Interesting.
So the most heat is generated when you're fast charging. From the beginning, we just said we have to have incredibly high rates of fast charging. And so we carry around this thermal system, and the peak use of it is during charging. We do a ton of manual manufacturing here.
Yeah.
Humans are making a lot of this stuff. We do have robots, but generally the robots are only there if something has to be done exactly the same way every time. It's there for quality, not for speed or cost. Every step of the way, we have people looking at what's happening. Here we are at a table where some of the electronics are laid out that we designed from scratch. We make it here on this floor. Every one of these units we make gets tested on our floor as well, and then heads down to Marina to get built into the airplane. The amazing thing is we brought on people here in Silicon Valley. We have talent across the board. We brought on people who worked at consumer products, things like making cell phones. We brought in people who work on medical devices, stuff that's implanted in your body.
Yeah.
People who worked at electric vehicle companies, the whole gamut, really. And you bring together the best solutions from all those industries, essentially figure out how to make it aviation grade.
Why did you choose to come to Joby? What was the story there?
So back in 2017, Jovan invited me out to see the airplane. And they had the very first full-scale airplane built up. And I got to see the initial bring up of that airplane, and then I got to see one of the first few times it hovered.
What would that feel like?
It was unbelievable. As soon as I saw that plane take off, seeing it up close, hearing it, it just took my breath away. And I was like, okay, the next frontier is in the air.
Yeah. So thanks for checking out Joby Aviation with me today, but this company's got a lot more going on under the hood or under the wing, if you know what I mean. Lots of cool projects. So let me know what you want to see in the comments below, and I'll see you on the next episode of Joby Recon. This is Joby Aviation. Welcome to the future of flight.